to Fascinating Frontiers, episode 122. It's July 5th, 2026. Here's what's happening in space and science today. Astronomers just found giant planets lighter than cotton candy, forcing a rethink of how worlds assemble. Two newly characterized worlds match Jupiter in size, yet contain far less mass, placing them at the extreme end of the super puff category. The planets orbit stars roughly 300 light-years away and were identified through combined transit and radial velocity data. Their densities fall below 0.1 grams per cubic centimeter, lower than any previously measured gas giant. Researchers note that standard core accretion models struggle to build such voluminous envelopes before the protoplanetary disk dissipates. Follow-up atmospheric observations with large ground-based telescopes are already scheduled to search for haze or extended envelopes that could explain the low densities. According to reports from phys.org, the combination of transit timing and velocity shifts pins the radii near one Jupiter radius, while masses sit at only a few tens of Earth masses. Next-generation spectrographs on extremely large telescopes will soon search for the extended hazes or outflows that could explain the observed sizes. If Earth's average density were scaled to the size of these worlds, the resulting object would float in a swimming pool like a beach ball. In reality, the planets formed farther from their stars, where cooler temperatures allowed them to accrete thick hydrogen-helium layers before the disk gas dispersed. Once assembled, the envelopes stayed puffy because internal heat from formation plus possible tidal heating slowed the cooling and contraction that normally shrinks gas giants over time. One surprising number stands out. The surface gravity on these worlds is only about 1/10 that of Jupiter, yet they still hold on to atmospheres measured in thousands of kilometers. The open question is whether the low gravity plus stellar irradiation will eventually drive hydrodynamic escape that strips the envelopes entirely, or whether an unseen high-altitude haze layer can shield the gas long enough for the planets to survive to the present day. From the extreme low-density worlds, we now turn to another population of planets whose sheer numbers may soon affect our ability to study any worlds at all. A new analysis quantifies how reflected sunlight and radio leakage from the projected mega-constellations will affect both optical and radio observatories. The study models cumulative sky brightness increases across multiple latitude bands and frequency windows. Ground-based surveys are expected to lose the largest fraction of observing time to satellite trails. Mitigation proposals include darkening satellite surfaces and coordinating with operators on orbital planes. According to Space News, the projected total reaches 1.7 million satellites. While satellite fleets pose challenges for future observations, one nearby world is already giving astronomers fresh reasons for optimism. Refined measurements of the planet's radius and orbital period have lowered its density estimate and placed it closer to the runaway greenhouse boundary than earlier models suggested. The world orbits a nearby M-dwarf star, allowing repeated transit observations that tighten constraints on possible atmospheres. Updated climate simulations now include the possibility of surface liquid water under certain cloud and haze scenarios. Additional radial velocity data are being collected to pin down the planet's mass and bulk composition, shifting from individual worlds to the hardware that gets us there. A European launcher developer is quietly upgrading its vehicle. Adding a fourth Prometheus engine to the first stage would raise expendable low Earth orbit capacity from 4 to 8 tons without raising average cost per launch. The change keeps the vehicle in the medium lift class while removing reusability hardware for maximum performance. Company engineers state the modification requires no increase in structural mass or tank volume. First flight of the 4-engine configuration remains targeted for 2027. Another payload heading to orbit soon is not a satellite, but a semiconductor test bed riding alongside Starlink. Two semiconductor processing pods developed by Bessex Space Industries will ride the Starlink 1050 mission scheduled for liftoff at 6:50 a.m. Eastern Daylight Time. The pods will test thin film deposition and etching processes in microgravity for several weeks. Data returned after the test will inform designs for future in-space manufacturing platforms. The mission marks the first orbital demonstration of this particular semiconductor hardware. While new hardware heads upward, researchers on the ground are preparing for New Horizons' eventual crossing into true interstellar space. Southwest Research Institute scientists are coupling solar wind measurements with heliosphere models to predict the location of the heliopause boundary. New Horizons will cross. The method uses existing data from earlier spacecraft to calibrate the transition region where solar wind pressure equals interstellar pressure. Accurate forecasts will help the mission team schedule instrument operations during the crossing. The spacecraft continues to return data from beyond 55 AU. From the edge of the solar system, we drop back to our own planet's extreme environments being used as stand-ins for future crewed missions. A new study compares human performance metrics collected at Antarctic research stations with astronaut operational protocols used on long-duration flights. Researchers recorded sleep patterns, cognitive test scores, and habitat habitability data under extreme isolation. Results indicate that certain geological and operational stressors translate directly to lunar or Martian surface conditions. The work supports expanded use of Antarctic sites for future mission simulations. In the pre-dawn sky this Sunday, Saturn's largest moon, Titan, appears close to the planet, joined by several smaller moons that modest telescopes can resolve. The alignment lets observers follow the satellite's changing positions across multiple nights without specialized gear, beyond steady atmospheric conditions. The same morning also places Mars and Uranus in a wide conjunction low in the wind, with positions shifting noticeably over the coming week. Observers are encouraged to log those movements to track the configuration's rapid evolution. The viewing opportunity comes from Astronomy magazine's July 5th Sky Preview. A 21-panel mosaic assembled at Kagakama Remote Observatory captures intricate filaments across one section of the Vela supernova remnant. Roughly 30 hours of narrow-band exposures were processed separately before final alignment to emphasize shock fronts where expanding debris meets interstellar material. Continued monitoring over the next decade could reveal measurable proper motion in the brightest filaments. The image highlights the remnant's ongoing interaction with surrounding gas and dust. The work appears in recent r/space discussions of deep sky imaging projects. NASA's Curiosity rover has started detailed imaging and compositional analysis of polygonal ground patterns on the floor of Gale Crater. Early spectra point to possible repeated cycles of wetting and drying recorded in ancient lake sediments. Scientists are comparing the structures with terrestrial analogs to narrow down formation timescales. Additional traverses will map how widespread the polygons remain across the crater floor. The effort is documented in recent updates shared on r/space. Astronomers may have caught an early galaxy in the process of dying. A massive system observed 1.4 billion years after the Big Bang displays extended tidal tails and stripped material consistent with ram pressure stripping by the surrounding intracluster medium. The galaxy offers a rare snapshot of the shift from active star formation to quiescence at high redshift. Further spectroscopy is already underway to measure remaining gas mass and current star formation rate. The findings are reported by phys.org. The Government Accountability Office report highlights rising costs for next-generation missile warning satellites, along with gaps in digital engineering practices within the Space Force portfolio. Workforce reductions at launch sites add schedule risk for national security missions. The review recommends improved cost estimating models and earlier integration of commercial launch providers. Congress has requested follow-up briefings within 90 days. Space News covered the assessment released this week. 60 years ago, the uncrewed AS-203 flight tested the Saturn IB's S-4B upper stage in orbit to qualify restart capability for later lunar missions. The stage executed a series of burns that demonstrated propellant settling and engine ignition under weightless conditions. Data from the flight directly informed procedures later used on Apollo 8 and subsequent missions. no payload flew beyond instrumentation and cameras. Recent R-Space retrospectives mark the anniversary of the odd Apollo test flight. Engineers transported the Apple satellite to an open field for antenna characterization tests that required a non-magnetic environment in 1981. The Bullock cart provided vibration isolation and avoided interference from vehicle electronics. The test campaign validated the satellite's communications payload ahead of its 1981 launch. Historical records from Japan, Korea, and the Arab world document a bright new star visible in daylight for 23 days on July 4, 1054. The event marked the core collapse death of a star estimated at 9 to 11 solar masses. Modern observations confirm the remnant contains a pulsar whose spin-down age matches the 1054 explosion date. Next time, keep an eye on the first data returns from those semiconductor test pods after the Falcon 9 liftoff. That's fascinating frontiers for today. If you enjoyed this, a rating or review on Apple Podcasts or Spotify really helps new listeners find the show. I'm Patrick in Vancouver. Thanks for exploring with me, and I'll see you next time. And if you'd rather watch than listen, find us on YouTube at NERA Network. Links in the show notes. And before you go, this show is part of the NERA Network, a family of daily podcasts on tech, science, and markets, each one a short, sharp briefing you can finish on the commute. If today earned its place in your feed, here's your next listen. Models and Agents, your daily briefing on AI models and agents. Find every show free at neranetwork.com. This episode used AI voice synthesis of my voice. Editorial selection and analysis are my own.
Drifting